Good afternoon, everyone. In this video, I will continue the discussion with class design steps for class design. Okay, we'll be discussing about recursing downward. Okay, and what is refactor. Let's look at them one after the other. So basically, you have to recurse downward. Okay, so basically, that means you have to organize operations as layers. Okay, and the operations in higher layers actually invoke operations in the lower layers. This is how you will be doing this sort of class design. Okay, so once you have identified those operations, then you have to organize those operations as layers. Okay, identifying the realizing the use case and identifying the operations we have already seen in the previous videos. So as I mentioned, operations in the higher layers actually invoke the operations in the lower layers. Okay, the design process generally actually works top down approach. Okay, we start with very high level operations, high level functionality, and proceed to define lower level operations. Okay, this is how generally the design process works. You can also basically work with start with bottom up approach. Okay, so you will have the sort of lower level functionalities, and slowly can start building higher level operations. Okay, but you will end up with risk of designing operations that are never needed. So design process generally follows this top-down approach. There are two ways of this sort of downward recursion. Okay, one is by functionality, another one is by mechanism. Let's see both of them. First, let us look at functionality layers. Okay, in this approach, we take the required functionality, high-level functionality, and break it into lesser operations. Okay. So then we have to basically make sure that we combine similar operations and attach the operations to the classes. Okay, that's what we have to take care of. So basically we are dividing. Okay, so we are taking the high level functionality and breaking it into lesser operations, and then we are actually attaching them to respective classes. Okay, functionality recursion may depend too much on the exact statement of the top level functionality. So in this case, say for example, if there are any changes to this top level functionality, okay, this will radically change the complete all these sort of lower level operations. So the complete decomposition is basically affected. Okay, this is one major issue with this functionality recursion. To guard against this, we must attach operations to classes definitely. Okay, so to the right classes, and we have to broaden these classes for reuse purposes. Okay, so as long as we actually support this operations become bigger. Okay, and then we join similar operations. Okay, and make them bigger operations, and then we design the classes properly. Okay, then these things can be reused. Okay, and this also basically guards us against this major problem that if there is any change in this sort of top level functionality, so the complete decomposition has to change. Okay, of course, at the end of the day, whatever the functionality or the operation which we are trying to define, design, it should be coherent. So that should be, it means it should be very clear, it should be meaningful, and it is not an arbitrary portion of code. Okay, say for example, if a function is doing certain activities, don't cut it into two pieces and then put them into two different operations. That's not an ideal way of designing an operation. Then the second approach here is this mechanism layers. So this is instead of taking the high level operations and then decompose them into lower level operations, what this does is, this mechanism layer is, we have to build the system out of the layers of needed support mechanisms, whatever is required for that particular system. Okay, say for example, in providing functionality, we may need to have various mechanisms to store the information. Okay, we have loop. Okay, so databases, access, and all those things, sequence control, how coordinating objects. Okay, so these are all these sort of mechanisms which are required. Okay, so transmitting the information. Okay, some communication mechanism for that. Well, we need to perform computations, so we need to have some sort of computation mechanism for that, and provide other types of computing infrastructure. Okay, these are all the mechanisms which are required for building such a system. Actually, these mechanisms will not be showing up explicitly in the higher level responsibilities of the system, but these things are required to make the system actually work. Okay, so something like if you have the building, okay, here's building, okay, so you have all these columns and then like beams and everything, okay. You will not be talking about all these things at the end, but then like they are the essential part of that particular architecture. Similarly, if you think in terms of computing architecture, this includes various kinds of general purpose mechanisms, something like here it is general purpose mechanisms. That means like we are actually reusing them at certain points, okay, for different systems actually. Data structures, algorithms, and control patterns, okay. These are again like general purpose mechanisms, okay. Of course, since they are general enough that we can actually reuse them at several places. Going back to our ATM example, we had that, okay, so we have several important mechanisms defined there. Say, for example, that application actually needed support for communications, okay, because like these ATM machines are existing somewhere, and then like the consortium computer is existing somewhere, and then like the actual banks are existing somewhere. So it is distributed infrastructure. At the same time, like you needed some communication. These are the basic mechanisms which are needed for building that particular application. In this way of recursive download or downward with this mechanism based layers, okay, so you basically start building as per these sort of mechanisms, layers across these mechanisms. But if you look at both the approaches, both have some advantages and some disadvantages, okay. Any large system mixes functionality layers and mechanism layers. Definitely it has to mix both the things. A system designed entirely with functionality recursion is a little bit brittle, okay. It is super sensitive to changes in requirements, okay. That's the problem when you recurse downwards only with functionality, okay. Whereas with the other one, if you basically build only with the hierarchy of mechanisms, okay, it doesn't do anything actually, okay. It will not be doing anything useful at all, okay. Only it looks like a system for learning purpose bits and pieces, okay, that's all, okay. So we need to have a large system should mix both these approaches, and part of the design process is to select the appropriate mix of both these approaches, and that's why like we are actually discussing this as part of this class design. Hope that is clear. Now next comes the refactoring. Actually, refactoring is changes to the internal structure of the software to basically improve its design without altering external functionality. You are not changing anything which is outside visible or like anything which the system is trying to interact with. Okay, so you will be changing the internal functionality to make the design better. Okay, the initial design of a set of operations will contain inconsistencies. Okay, so it will have definitely redundancies. You will have the same method existing in different classes and everything. Okay, and it will also have all these inefficiencies. Okay, it is impossible to get a large design correct in one pass. Okay, so that's why like this complete object oriented design development itself is an iterative process we have been talking about. This refactoring is also talking the same thing. We must revisit our design and rework the classes and operations so that they actually cleanly satisfy all their users and are conceptually sound. Regularly, like you have to follow this step. Okay, so and that's how like it is also one of the important step in this class design. After you have identified all these realized use cases, and then like you have identified all the operations, and then like of course like you also have recursively downward you came, and then like you started, okay, developing operations, okay, decomposing the operations, etc. Once you have done that one, you have to definitely refactor. Okay, so refactoring may actually seem like waste of time, okay, because like you're doing it again, okay, but it is an essential part of good engineering process. Only after you do these rounds several times that your design, whatever you have come out with, will be sound, and then like it will be reusable, and then like it is efficient. Now regarding the reference concept, we are still in chapter 15, object oriented modeling and design with UML. Michael Blaha and James Somba. Thank you very much for your attention.